Hi, my name is Gloriana Fattimia Amadea from BEEI-1/1. Uh, our project is FM radio transmitter. FM is short for frequency modulation, which refers to the means of encoding the audio signal on the carrier frequency. In general, a radio control system consists of a transmitter or transmitter, a receiver or receiver, and several servo as a driver. The battery as a power source is required by the transmitter and receiver. A resistor is a passive electronic component which has a certain resistance value or resistance which serves to limit and charge electric currents in an electronic circuit. An inductor is a passive electronic component that can store energy in a magnetic field generated by an electric current passing through it. Last is capacitors. Capacitors is an electronic components also that have the ability to store electrons. Components are used to store electronic charge. So this is our circuit that we built before simulation in multisim. Here we use 11 resistor, 9 capacitor, and 2 inductors. And also we use DC power 9 voltage as a source. And we use 292 and 3904. Okay, this is when we do simulation, the result. After this, we will give you a simulation.
The purpose of us in doing this topic is because the requirement given is to do RLC circuit. We choose to do FM radio transmitter because radio is used broadly in every country. We want to deeply understand the concept of FM radio transmission and how the configuration and value of components affect the signal transmitter. In this project, we have used a total of 25 components. The components used are resistors, electrolytic capacitors and capacitors, inductors, NPN transistors, wires, breadboard, multimeter to test the value of components, plier to cut the wires, DC power supply, and signal analyzer to observe the output signal.
So this is our FM radio transmitter hardware circuit on the breadboard. Here we are designing a simple single stage common emitter amplifier as strictly amplifier. We have an electrolytic capacitor 10 picofarad connected to a 1K resistor. The purpose of this resistor is to limit the current. This resistor is then connected to a 47 picofarad electrolytic capacitor in series. This capacitor serves the purpose of modulating the current going through the transistor. A large value indicates low frequency, whereas a lesser value indicates treble. So this capacitor is connected to a 68K resistor and 15K resistor. Is connected to the base of the T1 transistor 2N3904. Then we have a 4.7K resistor joined to a 10 micro electrolytic capacitor connected to the collector of Q1 transistor. On the below part of the circuit, we have a 15K resistor, 1K resistor and a 10 nanofarad capacitor all connected to ground.
This is C5 and L1 connected in parallel. The frequency of oscillation is given by F equal 1 over 2 pi square root LC, and our calculation is 1 over 2 pi square root 1 micro and 12 pico, and we get 37.51 MHz. For a better frequency, we require a frequency between 88 MHz to 100 MHz. For this, we can use a 0.2 micro Henry inductor and 12 pico capacitor value. Then this is C6 and 5 picofarad capacitor. This capacitor serves the purpose of keeping the tank circuit to vibrate. We are using 2N3904 transistor, and we prefer the value of C9 between 4 to 10 picofarad. Here we select 5 picofarad capacitor. And this is R6 and R8. Using the same method of calculation of bias resistors as in the pre-amplifier design, we select the values of bias resistors R6 and R8 to be 8 kilo ohm and 4.7 kilo ohm respectively. And now the selection of emitter resistor R9. Using the same calculation as for the amplifier circuit, we get the value of emitter resistor to be around 1 kilo ohm, and this is the 1 kilo ohm resistor.
Okay, this carrier frequency can be varied using the 18 picofarad capacitor connected parallelly with the 1 microhenry inductor, and the typical frequency band of this particular design is between the 88 MHz to 108 MHz. And since there is no visual output to recognize the exact frequency at which the transmitter is working, you will need to adjust your FM receiver radio within the range of the frequency mentioned to get the frequency at which the transmitter is transmitting. After modulating the audio signal with the carrier frequency, the signal is then sent out through the antenna, which is the output. All of this connection is in DC, connected with 9V battery.
Due to the limitation of lab equipment, we only have the output result of signal analyzer using the multisim software. The analysis type we use is time domain signal with 100 kHz sampling rate. The processed signal has an output of 9V amplitude, which is the same as the DC source used. From the signal analyzer, we can observe the transmission of FM radio slowly decreases as time goes by. Thank you.